سامح كنتوش was a paper titled Sustainable Management of River Basin and Reservoirs.
Tell you something that 10 years ago we met together with Dr. Sameh in Japan during one of these conferences, and since that time we are friends. He's one of the unique in his topic, Dr. Sameh.
Thanks so much, Chairman. Thanks for your introduction, yes, of course. And today I have the pleasure to give a speech about sustainable management of river basin and reservoir. It's some pieces of the puzzle about my research during my stay in laboratory of hydraulic construction in Switzerland, and Kyoto University and in Japan also, and also for the current research at the German University in Cairo. In beginning, in this map, we can see that this example of river basin, and we have several segments in the river basin itself, and several segments which show if we have dams and the reservoir, and downstream of this dam there is no connection, and the geomorphology, continuity of the geomorphology is stopped by these dams. So the sustainability of river basins and the reservoir itself is endangered by sedimentation, which is stopping by the dam. And the water and sediment incorporation manipulate the objectives to maximize the benefit, how to maximize the benefit of increasing reservoir storage and reducing the dam impacts. These dam impacts can be in 2 points. First one, dam modify the flow regime downstream, as we can see, because of geomorphology, and also discontinuity of sediment transport to downstream, which causing, it's not a question of only water, stopping also water flow. So we have 2 issues, quantity and quality. Quantity from the flow is adapting the flow downstream the river, in the river basin, and changing the quality because this sediment is some like food for the microorganism and habitat downstream river. So in order to have a healthy river, the continuity should be exist. And such kind of, we can say that the reduction of storage capacity by reservoir sedimentation, this is one of the impact. Downstream geomorphology, downstream hydrology is changing the water table by these dams and ecosystem. Of course, in order to say that the sediment routing system in a river basin, if we have a dam, so we have some sedimentations, and in Japan they're using the Sabo dam in the upstream, so it's like check dams to stop the sediment from the catchment area coming to the reservoir. But this sedimentation makes or reduce lots of impacts, and less sediment will be nourished to the coastal area and causing a lot of coastal erosion and river environment change as a physical ecological impact. So our objectives is to how to maximize the benefit from the dam. We would like to leave the dam to live forever, at least let's say the scenario is 1,000 years, and reduce the dam impact by balancing of sediment transport, the source of river to the coast. So from that concept, we would like to talk about the sustainability of a reservoir, and this sustainability we can see here as if we have, this is the time, and this is the water supply reliability for the dam. Dam is constructed and the reservoir already is full, storage capacity is full, but with time, because of sedimentation, this storage will be declined and reducing. And in the beginning, of course, is the very slow reduction of the sediment, and the storage volume will be eventually rapid reduction after long term, and finally we have to decommissioning a dam. And in that sense, we have to have the sustainability of reservoir should seek the balancing of the sediment. How we can do that? With the time, this is some conceptual model I have drawn. In order to, here is the original reservoir capacity, but if we have some sediment management technique or strategy in order to keep the continuity of the dam itself, so we can recover again the reservoir capacity. So this is the idea, and by removing some sediment from time to time, that will keep the storage exist. But in order to guarantee the security and acceptance function, we have to use several, either one strategy or several strategies. So if we have, this is the duration, and here the reservoir capacity rate. In beginning, this is the decline, and always we design the dam for a return period, almost like 100-year return period. And if we don't do any action, so definitely it will be filled with sediment. But if we do some urgent measure, this storage will be recovered. But if we have a long-term one, so we can even go back to the original storage. So I will start with a small work which I did about numerical simulation. It was one problem in Egypt about 12 years ago or a little more. Here we have the delta of Nile River, and we have three lakes. These lakes for drainage purpose, but also especially well for Egypt. And that one of these lakes, the topic I am talking about, is the Etko Lake. Etko Lake has a problem during 2000 or 1999 and 2002, facing some floods around the region, and that we requested to study this by numerical simulation, and we have found that when we have, see, this is the original bed form, and this is the original water level, and the simulated one with different scenario. This is the root level. So we found that some big part of this area were flooded due to the sedimentation. And because of we, as a solution, we tried to dredge this peak of sediment, and it was solved the problem in order to keep the flow from this is the inlet of drain, Etko drain, and this is the lake. So we could, by dredging the sediment, we could achieve or solve the problem of temporary flood of this area. This model, physical model test in the laboratory hydraulic construction in Lausanne for problematic of Rhone River in Visp, and the idea is also how to find or how to control the flood by constructing a side weir in order to, during a high flood or peak flood, we can accept some flooding area, side weir impact. And in that case, we at Lausanne, in Lausanne, we construct this. Okay, we construct this physical model. It's a very large model, and here's some drawings in order to increase the river capacity to reduce the flood. And my part was doing large-scale particle image velocimetry in order to check the surface flow in the model itself. In order to change in, we have a new concept to have it in ground, still in basin, very deep reservoir, and naturally will be devolved with sediment deposition, and there is no cell, of course, and once the sediment deposited and filled with the sediment deposit in the basin, it will be evacuated to the downstream reach. And we have like several objectives for that, and here are some parameters, and based on, of course, some model scale. And yeah, this is the idea. This is the model we built in the lab. We have the flow, and we have some gate here or dam bottom outlet, and of course the sediment will be deposited, and naturally fish and sediment will be able to transport to downstream area. But we also thinking to construct some cylindrical tunnels in order to dissipate more energy.